Hello everyone, welcome to another episode of the Data Sense podcast. This is the show where you learn from technical and business leaders how to connect business and data to drive your business forward. Today we have Amar Raheja. Amar is a professor of computer science at California State Polytechnic University. Welcome to the podcast, Amar. So you're a professor, and obviously that's a long career path from even undergrad to being post PhD, postdoc, and then probably assistant professor, and now you're a professor. So, and you are a professor of computer science. So tell us, how did you end up being a professor of computer science, and what got you interested in the initial stages?
Yes, thank you. So I started, actually, I've had an interesting journey. I started as an undergraduate in physics. I was very passionate about that at that time. But after that, I realized, well, I need to do something a little bit more practical and apply my knowledge in, solving some real world problems. So I after, finishing my master's that was also related to physics, I decided to switch to biomedical engineering. So, when I did my PhD over here, I was always interested in the medical imaging world. So I actually decided to use my knowledge, and medical imaging, as you know, relates a lot of fields together, just not the physics of the imaging device, but it's also about the algorithms that go into reconstructing the data that the physicians look at, then the images, and of course, a lot of image processing and computer vision. So that was my stepping stone into the world of, using, data in general, which is what I'm doing right now in the field of computer vision. And then, of course, the time I graduated, biomedical engineering was still coming up as an academic field. So I kind of decided to stick to computer science in terms of developing algorithms in the world of computer vision. So I joined the academic world for a couple of years. I was at a different university in Philadelphia, and then I moved to California State Polytechnic University over here, where I've been for the last 20 plus years doing, teaching and research in this field of computer vision and data science.
That's really amazing. What's really interesting is that I also did maths and physics at the undergrad level, and you know what? I also felt, oh my God, physics is very abstract at this level, and maths is just way too abstract. And I also felt that, I need to do something practical. This is not what I like. I liked maths and physics at, college level, at school level. It was really interesting. And then I realized that, no, this is not what I wanted. And so I also sort of switched to computer science, but, programming basically. And here I am, at, being able to, as a consultant, being able to save over 23.5 million pounds for so many clients, including government departments. So it has been a journey which is quite similar. So yeah, I can definitely sense that, why it makes sense to go over on the dark side, maybe. So what's with that, you're working on very interesting projects. You're working on computer science, and you are computer vision. Computer vision. You are working with images. Do you work with 3D images as well? Is it mainly 2D? And what are you researching into this? Tell me something.
Right. Yeah. So maybe I can talk about two of my current research projects, that'll give you an idea of what. So the first project that I'm working on is related to the medical imaging world, as I mentioned, and of course, data science and machine learning. So right now, what's happening in the medical imaging world, there's a lot of development of what is called as computer-aided diagnosis, which is basically the use of computers that look at, say, the X-ray images of patients and determine what kind of thoracic diseases that they have, right? So, but of course, as these AI systems become prevalent in an everyday basis for diagnosis, the results that they produce have to be agreed upon by the radiologists, by the physicians, right? Because of course they have a much more accurate training of looking at data as opposed to computers. So what we are trying to figure out is one of the basic problems in AI and application of machine learning in data science is the bias that exists in the data, right? So your results are as good as the data that you're using to train the model, to create the
Yeah.
model, right? So specifically in something like this, what we are trying to figure out is if there is, an racial and ethnic imbalance, in the medical imaging data set that is being used to train the data for these CAD systems, correct? So if you don't show the training model enough data from all the different racial, ethnic, and gender data, then they're going to be producing incorrect results or not with good accuracy for those races that are not included in the data set.
Yeah.
So that's the bias that comes out. And this is in fact true, not just in this world, but in general of application of data, to train a
Yeah.
model in for any practical machine learning application that is out there. It's already been shown in different fields, in fact, even determining healthcare premiums,
Yeah.
there is
Yeah.
algorithms being used for that, so as industry makes these machine learning tools, I think it's important to keep an eye on.
Yeah.
And not only that, it's also about in terms of when you choose your data that you're going to be training your model with, what are the features in the data that you're going to use, correct? Sometimes you have hundreds of features. You got to narrow that down into might be choosing 20 that you feel are the most, important, or that will contribute to your desired, output or prediction that you're trying to do with this. So there's a lot of complexity in terms of using data in for machine learning models. So that's one of the things that we are trying to figure out, if there's this bias that exists, by using different kind of data sets and then prediction. You see, we can actually predict our thoracic diseases correctly if we use different data sets that are, equally balanced in terms of the representation. So that's one of the interesting projects, and still related to the biomedical world.
That's quite interesting. So I have a question. So regarding that, so you mentioned something really interesting, something I'm actually quite passionate about. So suppose you have to obviously take data from as many different scenarios as possible, right? So that when you put it to when you train the machine learning model, that generalizes well. That's what the idea is, right?
That is correct.
And so but you still have to include labels to show that this is this ethnic minority, or not ethnic minority only, but say of a different ethnic background, right? Do you have to include that as well?
Yes. So that's another interesting aspect, is getting data,
Yeah.
which for the different ethnic minorities, especially in the medical imaging world, which is very very careful about labeling data, and of course we have to remove all private information from the data before we can use it for training and so on. So, but yes, that's true that if you train your data set that doesn't have that representation of that particular ethnic or racial group, then how can you diagnose that?
Yeah, that's it. Yeah. So the thing is, I agree with that. The reason why I asked that question was that I remember there was an article about Amazon where they were using AI to train how to sift through so many job applications. And suddenly it became racist, but finding that there are certain ethnic minorities that don't get, or in fact some females don't get accepted as much, right? So there's a bias of the data. Then the AI is also biased. But the thing is that I thought that that makes sense for obviously job, right? So the applying for jobs is different. But for medical, I know that certain backgrounds, certain ethnic backgrounds have certain kinds of foods, right? and then the whole culture eats that sort of food, or they have the whole culture with that background of consuming the food in the same way, right? And so they're likely to have very similar medical problems, right? So it makes sense to include that ethnic minorities or ethnic backgrounds label that, yeah, these are people from Pakistan or India or Southeast Asia, something like
Right.
that, so that that this is more common in that background because of maybe the oil, maybe there's too much
Yeah.
spices
Mm.
or whatever that is in the food, right? So
True.
what would you say to that?
Well, that's true. I think what is important to note is that how, if, especially from a physician perspective, or especially in this case, a radiologist perspective, does the same disease manifest itself exactly in the same way, right? In the images of different racial or ethnic groups, right? So if you're trying to predict, say, a particular thoracic disease, right? Is it being manifested in the same way, or as you mentioned, because of our different, say eating habits or something, that's actually manifested slightly differently? It might be a similar problem, but
Hmm.
manifested slightly differently, correct? And of course, a trained physician, or radiologist can probably capture it much more accurately based on their experience of looking at
Yeah.
these images and knowledge of that, right? But how does that translate to your machine learning model?
Hmm.
Correct. And the only way that can translate is if the machine learning model has seen enough of these images to realize that, yes, this manifestation from this particular group is a little bit different, might be for the same problem.
Hmm.
So
Yeah, I
so
agree.
you're right about
Yeah. Yeah, so what's really what's I guess a limitation of machine learning here is that I recently saw a tweet where it was showing Tesla car
it. Hmm.
driving through a road, and then it often has this screen when you're training the AI driving driving script or AI bot. Um,
Hmm.
it basically shows you what's in front of the road, what's in front of you in the actual screen. So it's trying to say that, okay, if it's a car, then it will show you that there's a car in front, right? It will label the car and say this is a car. If it's a
Hmm.
truck, it will say it's a truck. If
Right.
it's um if it's a bike, it's gonna say it's a bike. If it's a motorbike, it's gonna say it's motorbike, whatever. And the thing is that, but there's two scenarios it had not seen. One was, which is a really funny one. One was a truck, but a small truck carrying portable traffic lights. So it was carrying portable traffic lights that are going somewhere, right? Because they are basically putting those portable traffic lights in some roadside location for
Hmm.
because they have to block off the road for maintenance, right? So now they're putting these traffic lights to control traffic. Now, the thing is that it was not recognizing that this is a truck carrying portable traffic lights. All it was recognizing was that it's traffic lights upon traffic lights upon traffic lights. It's like the traffic lights are moving. It's like so many traffic lights,
That's
right? Oh,
interesting.
that's all it's saying. That's all it's because it's not told that this is a truck moving in front of you. It's moving. It has traffic lights on it, but it's not actually traffic lights. So that was one example. The other one, which was really funny, was that basically a horse cart, right? A horse carriage was basically in front of the Tesla car, and the Tesla camera was just going mad. Was basically, is it a truck? Is it a car? Is it a truck facing this way? Is it a what is it? It's trying to
Right.
guess. It's trying to label it everything, and it's just not
Right.
able to label it. So it basically shows that if it doesn't know, if it doesn't have data before trained
Hmm.
labeled, it simply cannot generalize enough for that
Right.
scenario. That's the uh, general limitation of machine learning, which is that's the I guess the issue.
Right. Right. And it's going to mislabel it, right?
Yeah,
So because it has to choose only from a few labels that it has been
yeah,
shown during the training process. And then, of
yeah,
course, in this case, it can lead to more critical, dangerous
Yeah.
accidents and so on. So that's the interesting thing about machine learning is, especially applied to the real world, you have to think about all possible scenarios and actually gather training data to capture
Yeah.
all those scenarios. And
Yeah.
that'll happen over time, probably not, even if, so now there's data of something like this. So now they'll be aware that next time let's put something, even though it's a very rare chance that something like this will happen.
Yeah.
See a
Exactly. Yeah.
moving
Yeah.
traffic lights. But
Yeah.
that's
Exactly.
right about that. I
Yeah.
didn't
So
want
that's
to go ahead.
so yeah. That's basically the limitation which we have to be careful of,
Hmm.
even when using machine learning. Yeah. So what's the with that? How do you also work with 3D data as well, or um, because obviously 3D data adds another dimension of complexity to the problem.
Right, right. So far, I haven't really worked as such with three-dimensional data in terms of machine learning. I do have another interesting project that we are working where we are trying to actually predict the health of plants, you know, uh, uh, using machine learning models, and this is in the field of precision agriculture, which I think is very important given how we are trying to feed the world from reducing land and
Hmm.
reducing resources like water.
Yeah.
So it's another project that I have been working on where we try to gather, we try to fly drones with sensors over huge fields, trying to gather images, not just in the visible range, but in the hyperspectral range as well, data, which can be considered actually as multidimensional. Since you mentioned three-dimensional, this is
Right.
multidimensional data because it
Right.
has
Yeah.
many spectral bands.
Many spectrum
So
bands.
yes,
Yeah.
so in that sense, yes, that is kind of multidimensional data. And then we are trying to see if we can create a model, that can map that data to the actual ground truth.
Yeah.
So we actually also collect ground truth data by actually using sensors, say that measures the chlorophyll of the plant or the water potential of the plant, which is actually what is used to determine how well the plant is doing. And
Yeah.
then we try to map that to create a model, to determine whether the plant is doing well. Because then it's easier once you have a trained model, you can pretty much think of flying the drone with the sensors every day over the field, and generating areas of plants that might not be doing well,
Yeah.
and then just focus your resources on, say, watering just that area rather than watering the whole field, or spraying, chemicals if there's disease in that area, just specifically to that particular plant. So that's the idea of precision agriculture, and also even trying to figure out the yield of a plant before it gets to the point where you're harvesting it. So like we're working on, say, strawberries.
Hmm.
Can we determine strawberries when they start growing in an early stage, and then determine, a few weeks later when they're ready to harvest, what will be the actual yield? So that's
Hmm.
again another, use of prediction of, so there we're trying to identify what is a strawberry, what is not a strawberry by looking at
Okay.
a plant.
So yeah,
Yeah.
that's quite interesting. So then, with that, how much data do you have to collect? How many
Oh,
pictures?
a lot. That's another problem in the field of data science, right? I mean, like especially multispectral data, hyperspectral data, right? It is
Hmm.
gigabytes and gigabytes of data, and so we are trying to fly these drones with our cameras, over the fields, every a few days, trying to capture all, throughout the cycle of the plant, from when it starts growing to when it's ready for harvesting. So, so it's like almost terabytes of data. And then, of
Hmm.
course, training this data, trying to mine, or you use it for developing a trained model, is, of course, another challenging task.
Hmm.
So, and especially doing it in a way where we are trying to accurately figure out, right? Because a lot of times plant health is not something you can just determine also by visually looking, right? Until it gets to a stage where it's really dying, or, you can see it. Uh, so we're trying to pick up those nuances early on in the health of the plant, such that you can focus your resources on improving the health, just for a specific location.
So with that, do you train your models on the cloud or on your university supercomputers?
So we do both. I mean, the cloud space obviously is it's limited and has restrictions, but we do have our own um, systems as well in the university that have
Hmm.
many multiple nodes, and
Yeah,
much faster and locally accessible. So,
yeah,
so, so of course, we our goal is to write research grants and request more resources so we can do this more locally. And sometimes we also train our models from scratch rather than using pre-trained weights and then training the last few layers. We try to train from scratch as well. That takes much longer,
yeah,
than using pre-trained models and just training the final few layers of
yeah.
the neural.
That's quite interesting. That's a lot of work. So
Yes, yes.
well, one thing I've felt is that AI is very behind when it comes to industry. Only say the top few companies, Google, Microsoft, Apple, Amazon, have a monopoly, or they are using AI as much as possible.
Mhm.
However, smaller companies or any company other than the bigger ones find it very difficult. And also, there's a whole sort of evolution they have to go through. First, have the right data, tidy up the data, work on projects that are beneficial, and only when it's proving really well and there's a whole data team set up properly, then machine learning makes sense. However, in in academia, um, AI is done. If you want to do, artificial intelligence, you're able to basically get into it very, very easily and do very advanced machine learning. Uh, I guess in a much earlier stage than if you were to try and do it in industry. So,
Mhm.
but you still obviously have to go through a lot of like grants, as you mentioned, and then make sure that the projects are aligned with the funding, and so there's a lot of moving parts in that as well. What would you say to that? Do you feel academia is much ahead in AI than industry?
Um, so what I would say is that I think what the interesting part about being in academia and working on these multidisciplinary problems is that yes, it's much easier to get started, right? Because our goal is not motivated by having a product, right? I mean, yes, if it does get to that stage, then you do hear of a lot of professors might be starting companies on the side and or collaborating with industry to get this into a product, right? So that's, I think, one of the pressures of being in industry is that you have to move things much faster so that you can get to that product stage, uh, uh, which is not there in academia. So it's much easier to pick up an interesting real world problem and start applying machine learning to that, which is what I try to do in multidisciplinary teams, because there is, other than the pressure of getting grants to support your research, there is no other pressure of okay, we have limited time, we need to get you know uh, all of these different funding goals and the product out there so we are revenue positive, right? So that pressure is
Yeah.
not there. So in that sense, yes, academia does lay a groundwork for a lot of interesting, testing of interesting ideas that can obviously become uh, the foundation of products in the future.
Hmm. So that's quite interesting. Now that brings me to another question. What are the technical challenges you face with implementation of machine learning? So sorry about that. Sorry about that. I'll just repeat the question one second.
Mm. No worries.
Okay. So that brings me to another interesting point. What are the technical challenges as you implement machine learning problems? Obviously, data is one thing.
Mhm.
Training from scratch,
Mhm.
a lot of data, terabytes of data you have to deal with. Um, is that it, or do you have bigger challenges? Um, and are the bigger challenges more in the sense that it's machine learning algorithm problem, or is it just in the sense that you have to satisfy ethics, you have to make sure you are using the data which is accurately representing all these scenarios? What
Right.
are the what's the biggest challenge you face in academia with artificial intelligence?
Well, so I think it depends on the problem that we are trying to solve, right? Using machine learning. So yes, there are these technical challenges in terms of creating accurate data sets. I think that's what I try to focus more on, because I know that uh, not having that accurate data set can create a lot of bias, which then of course results in incorrect use of the model. So yes, so cleaning up the data, right? Deciding what features of the data you really want to use, right? So narrowing it down to a manageable set of features for the data, correct? Because the more features you have, you might feel like it's definitely
Yeah,
better, but it takes a much longer time to train the model, right?
yeah,
And there might be a lot of correlation with some of the features within the data set, right? So trying to understand how to choose the actual features that are going to truly contribute to the model working well. That's another challenge, right? So you can try using different features, creating different data sets, right? And depending on the problem, again, also making sure that there is the whole aspect of ethics involved if the data relates directly to humans and being applied, to something which is very critical for, like I mentioned, in the
yeah,
diagnosis of disease or something like that. So there's all of these aspects together, which are the technical challenges, apart from, of course, the aspects of, being able to store the data and do the training, whether it's locally or on the cloud and so on. So those challenges obviously always remain. But I think these are the bigger challenges that I try to, focus on, is making sure your data is really clean and has covered, or seen all the scenarios, for even like for plant health, I want to make sure the data has seen every possible type of plant, right? Whether it's close to dying or it's very healthy or it's, somewhere in between. And because that's what then determines how well your trained model works.
Hmm.
Uh,
So yeah, so with when you are already taking a lot of pictures of say fields, right? You're taking a lot of pictures using a drone of fields, trying to find, trying to obviously collect as much data as possible.
correct.
Do you also, would you say it would make sense to use data where it's somewhat synthetic data, not fully synthetic, but say you use the image as it is, but then you create duplicates of that image and maybe add noise to it. Do you do that sort of work, or do you just take a picture and a bit of processing and then you take that as it is as input?
Yes. So far we haven't really added any noise. There is nothing synthetic about, we take the images, after some pre-processing, we take them as it is.
Hmm.
I mean, that could be interesting in this. I mean, again, depending on a different kind of an application, where, say, for example, if you're trying to, denoise images using some sort of machine learning model,
Yeah.
there it might be interesting to generate these kind of synthetic images by adding noise, you know, not just. I mean, I could see that in the world of astronomy, or something like that, where you're collecting images from telescopes and stuff like
Yeah.
that, where there's a lot of noise, atmospheric noise and so on, right? There are certain established noise models where you can then, use that to add into good images and then use that for training if you want to clean them up and stuff like that. But so far, at least for my projects and research that I've done so far, I haven't really been, using any sort of synthetic data.
Okay, that's quite cool. That's quite interesting.
Mm.
I guess you're able to, have enough data that's as real as possible,
Mm-hmm.
uh, and so you're able to use that instead of having to generate some synthetic data to support your training. So yeah, that makes sense. That's a quite interesting way of doing that. actually.
Right, right. And
Uh,
that's why it takes a long time to collect this data for us,
yeah.
because we have to go through the whole cycle of the plant. We did a similar study with grass as well, trying to figure out the health of grass, because grass gets watered all the time, the entire surface, rather than just choosing portions of the grass where it's not as green. So
Hmm.
things like that. So we have collected data, like, seeing, where you can find possible variations that capture
Hmm.
the entire gamut, of
Cool.
images and health.
Yeah, that's quite interesting. Yeah. Um, and whereas in the industry, often there's a lot of synthetic data involved. In fact,
Hmm.
synthetic data is like part of one way of speeding up collection of data, or curating a lot of data, because obviously sometimes it's too difficult to collect enough data to train a machine learning model to do
Hmm.
something well enough quickly.
Hmm.
So for in industry, there are a lot of use cases where synthetic data just makes sense,
True.
which is quite funny, right? Because what you're doing is you're creating data through another program, another computer program, right? Application, and then you're feeding it back to another application and saying, "Here's some data," right? So it's quite interesting in that sense, and I hope that we are able to get to those machine learning models that don't require so much data, that can
Yeah.
work, can generalize with less data, with as less data as possible. That would be really great.
Yes, that would be, but it would be a little tricky as to how you capture every possible scenario as your
Well,
data set reduces. So it depends on the
yes,
application you're trying to use it for. Yeah.
yeah. So it's a bit like it will be closer to how humans understand the world, right? When you, for example, when you tell a baby, or no, babe, when you tell a child, this is a dog, right, and this is a
Hmm.
cat, you only have to tell them once or twice, right? And then that's it. They know that this is a dog, this is a dog, this is a dog, cat, 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 all of that, right? Whereas
Hmm.
a computer, we're telling 10,000 times, this is a dog, this is a dog, and so and so. Uh, but at least if you could reduce it down 10 times, right? Only tell it 1,000 times. That would be great. If you reduce it down to only a handful of images and say these are dogs, these are cats, right? Now, hopefully you recognize them well enough, and that's it. Maybe obviously human eyes see 3D, right? And they're able to see from various different angles. And
Right.
maybe that's all you need to show to the machine learning model, that, okay, this is a dog, see it from all the angles, see it in three-dimensional space. And once you've seen it, that's it. That should be enough, right? And then generalize enough to a certain extent. Obviously, there are some cats that look like dogs and some
Mhm.
dogs that look like cats, some breeds.
Right.
And then if the machine learning model gets it wrong, that's fine. That's understandable. So,
So in the end, it boils down to, like, what are those key signatures, right, of a
yeah,
dog or a cat in the data that you're trying to use for your model,
yeah,
right? So of course we're trying to extract features from these images, right, and use that for training. Maybe if we can, there's some way to figure out what are those real, key signatures, you know, features of the
yeah.
data, that so you can reduce the data set overall, as long as those are the ones that are the most important in figuring out or distinguishing between a dog and a cat.
Yeah, yeah, I,
But that's
I, I
only
agree.
if
Yeah.
you
So
see it.
it's back to the exact features that you pick out. Yeah, like whiskers and that sort of
So
thing.
maybe our brain is really good at determining those features
Yeah,
that we might only need to see it a few times,
yeah.
as opposed to a machine.
Yeah, I agree. Yeah. So
Yeah.
what's one thing you advocate that you would like to see in in AI, which isn't the case right now? In AI, in academia, or in an industry, how we use data, it could be anything.
Uh, so I think the only thing that really, um, I shouldn't say bothers me, but I'm always wary of, that now we see the prevalent use of machine learning, in pretty much everyday life, right? A lot of times we don't even realize that a lot of these decisions in our life are being made by trained models. And I
Hmm.
think, too, I hope that both academia, industry, wherever we are doing this research and creating these models which are being applied to daily life, that we have this ethics component involved, especially not have this bias, which I feel is already existing to a point where we might not realize that it does exist, right? And I think, and making sure that the future, machine learning models that are becoming a daily reality involve data that removes this bias. We've already seen, that bias is easy to propagate, right, based on the data. And
it is. Yeah, it is.
Yeah, it becomes very one-sided,
Yeah.
And so the truth is basically what we feed it, right? We're seeing the result of that, and I think that's the realization that still has to come. I feel in a lot of this application of machine learning, whether it's mainly being done in industry or in academia and so on. So keeping an eye out on that as these things become a more day-to-day reality, is I think what I would like to see going ahead. Which I think be a big benefit, to the daily use of these algorithms. Otherwise, it might not be a good end result. That's just my feeling of data science in general, and machine learning in general, how it's being applied today.
That makes sense. Yeah, that's quite an interesting point. Because I've seen it that there's a lot of models being created, and sometimes the data is basically whatever you can fetch, right? If it's in industry, it's basically whatever you can fetch, get the data, and it's not the exciting part, right? The exciting part is the machine learning part. Oh, the model, writing the code, training the model, getting the higher accuracy score. That's the exciting part for people. And what they forget is the data engineering part is actually more important, more crucial, because it's garbage in equals garbage out. And you have to make sure whatever you give it is as accurately represented as possible. So yeah, that's the truth basically. And there's a huge aspect of how it should be done. That's something to think about. What isn't happening is that someone is not being very careful about the data. Everyone's thinking, oh yeah, let's do the cool bit, machine learning, only tweaking the models and then say, yeah, this is it, this is done.
True, and I completely agree with that. I think that that realization has to be there, right? Spend more time on the data engineering aspect, making sure that you've covered everything, keeping that idea of equity and all that stuff in mind, especially if it's an application that's being used on a daily basis to determine some aspect of human existence.
Yeah, that actually really annoys me the most. The whole idea that people are only thinking about tweaking the model and say, yeah, we want to do data science, and what they mean is writing a machine learning model. And the funny thing is that there's so much code available, so many templates available, that it's sometimes the easier bit, in what you're doing. Sometimes it's the easier bit, right? Like the code is already available, the algorithm's already there. The actual work is in the data engineering, right? And they're not doing the data engineering. And the other bit is that the actual work that's required afterwards is how you deploy that machine learning model, how you allow for anyone on the cloud to do inference on it, and how many inference can you take, and all sorts of like the cloud costs when you deploy that model. They're not thinking about that. They're only thinking about, oh, I want to tweak that model and then be a machine learning engineer, and that's good. That's all I like. I'm thinking this is not reflecting of what actually needs to be done.
Right, because the focus is more on let's apply this quickly, and somehow whether it's save money in something or whatever the end goal is, right? But
yeah, it's basically the cool technology, right? It's a cool technology. Let's work with the cool technology and maybe write it on our CVs and stuff and say we are cool, right? So that's
Hmm.
the issue basically.
Right. It is. I mean, it is a buzzword in today's
Yeah,
world, right? You have
yeah,
machine learning, and it's true. I mean, it is being applied to a lot of problems, but how diligently, is the
mm,
data actually being evaluated before
yeah,
it's used for? So it's very easy to apply a model, So whatever data you can get your hands on, you can try to do some sort of, prediction or clustering or whatever you want to do with the data, extract some sort of knowledge. But the question is, how valid is that knowledge? Because if your
yeah.
data is not valid enough, the knowledge is going to be, very biased.
Yeah, that is true.
Yeah.
So yeah, that brings us to the end of the podcast episode. Thank you for being on the show. And if anyone wants to get in touch with Amar, you can get in touch with him on his email or LinkedIn, which will be in the description below. Thank you so much.
Thank you, Zane. Thanks for having me. It was really nice talking to you.